All right, guys, welcome back. So this week is a little bit weird because we need a third test. For every quarter, you have to have 3, and we only have 2. So what the plan is we're going to do a very short, little kind of mini unit on sequences and series. So we'll do it today and Wednesday, and then y'all will take a very short test on Friday. That'll be your last test of the quarter, okay? Then next week, we'll review first semester exams, and then semester exams are the following week. If you haven't looked at the schedule, I did already put it on your Schoology, if you want to look at it later, okay? The week of exams, there's not going to be any tutoring. So you have this week tutoring, next week tutoring, and then exam week, you know, some of the days are short anyways, that you won't have tutoring then, okay? So today's notes, especially if you have a calculator, they're really not too bad. So a sequence is going to be a list of numbers in a particular order that follow a pattern, or sometimes this is called a function rule. So A1 is going to stand for the first number in the sequence. A2 would be the second number in the sequence. A3 would be the third, A4 would be the fourth, blah, blah, blah. So AN would be the nth number in the sequence. And the pattern that you use, or the function rule, is how you can find each term in the sequence. Okay, but if you have the rule, let's say you want like the 100th term, then rather than you having to write the list out all the way to the 100th number, the function rule will just let you basically like skip ahead. So let's generate a few sequences and see if you kind of get the idea. So for the first one, it's AN equals 4n minus 2. Then A1, you're going to plug in a 1 where the n is. So instead of 4n minus 2, now it's 1 minus 2. Now, if you want to use your calculator, you can. This is easy enough that you could do it in your head. What's 4 times 1? Take away 2 is 2. A2. Instead of plugging in a 1, what are we plugging in this time? 4 times 2 minus 2. What's 4 times 2? 8 take away 2 is 6. Next, we're going to find A3. 4 times 3 minus 2. It is going to be 10 because 4 times 3 is 12. Take away 2, that gives me the 10. Okay, now notice it says in the instructions here, find the first 4 terms. So I've already got 1, 2, 3. This is going to be my last one is A4. And it'd be 4 times 4 minus 2. What's 4 times 4? 16, take away 2? 14. So my sequence, or my list of numbers in a particular order that follow a pattern, is 2, 6, 10, 14, ... Okay, and obviously you could extend that list as many terms as you want. We only went to 4 because that's what the instructions say. All right, one more pattern. Look at B. Same thing though, just the first 4. So I'm going to find A1 first. My n is going to sub out for a 1 squared plus 1. 1 squared is 1 times 1. What's that? 1 times 1 is 1, and then plus 1 more would be 2. Next, I want A2. That's going to be 2 squared plus 1. 2 squared is 2 times 2. What's that? 4 plus 1 more? 5. The second number is a 5. A3 is going to be 3 squared plus 1. What's 3 squared? 3 times 3 is 9, plus 1 more is 10 for the next digit. Okay, last one we're finding is a 4. That would be 4 squared plus 1. Again, you could just put it in your calculator if you want, but 4 squared is 16. Add 1 to it, you get 17. So your sequence would be 2, 5, 10, 17, ... Okay, now there are 2 special types of sequences. Okay, you can see it in the top of your notes. You have an arithmetic and a geometric. Okay, the difference is, so geometric or arithmetic. Okay, and the difference is based on what the pattern is. If it is an arithmetic sequence, okay, it is either a plus or a minus pattern. So you're always adding the same number or minusing the same number, but if it's a plus or minus pattern, it's called arithmetic. Okay, then over here, we're gonna call the common difference, meaning like the number you always add or subtract, D for difference. So if it's plus or minus, you're going to use a D for what you're adding or subtracting each time. Geometric is if it's a multiply or divide pattern. And the number that you're always multiplying or dividing by is called the common ratio. So we're going to use an R if it's a ratio pattern. So take a look at the next couple of patterns. We're going to go one at a time and try and decide what the type of sequences. Is it arithmetic or geometric? And then based on that, what's the common difference or ratio? So look at the first pattern. It goes from 6 to 10 to 14 to 18. What's the pattern each time? +4. And if it's a +4 pattern, that means it's a difference of 4. And that makes it arithmetic. Because remember, arithmetic is plus or minus patterns. Okay, and actually, if you want to be lazy, maybe you could just put an A for arithmetic, G for geometric. Okay, go to number 2. I go from 10 to 20 to 40 to 80. What's the pattern? Times 2. And if it's a times 2, do I call that a difference or a ratio? Ratio, and that makes it geometric or arithmetic? Geometric, because remember, multiply patterns are geometric. Okay, let's just do one more. Take a look at number 3. 180, then 60, then 20. What does it look like they're doing each time? What's the pattern? Now, if they're dividing by 3, you can't make your ratio 3 because that means times 3 each time. So you're going to let your ratio be 1/3. So if it's a divide by pattern, and that's obviously geometric. Remember, geometric is multiply or divide. Okay, if it's a divide by pattern, you want to use a fraction here. So if it was divided by 5 each time, you do 1/5. Divide by 2 each time, do 1/2. Okay, yes?
So should we always put the plus or multiplication before the number?
You don't have to. I did just, you don't have to put the plus or the multiply. If you pick an R, it's implied as multiply. If you put a D and it's positive, it's implied as plus. Okay, last one, number 4. What's the pattern? 3, then 1, then -1. It's -2 each time. Very good. And if it's -2, then you need to make sure that your difference is a -2 each time. And does that make it arithmetic or geometric? Arithmetic. Okay. All right, go ahead and turn the page. All right, so what we're eventually leading this to is that when you have a list and you find out what type it is, you should be able to write the function rule. So up here at the top, I'm going to give you sort of the generic one, and then we'll do a couple of examples. So if your looking at an arithmetic sequence, remember, that means a plus or a minus pattern. Okay, a plus or a minus pattern. You're gonna do, it's A1 plus B. Okay, so take a look at the first question. It goes 1, then 5, then 9, then 13. What are they adding each time in number 1? So my common difference is a positive 4. Now, if you just put 4, that is the same, but I'm just putting the plus to show it's an added pattern. Okay, then your A sub n is going to be A1 is the first term in the list. What was the first term in this list? 1 plus 4 n minus 1 times. Now, let's talk about the n minus 1 because sometimes that can be tricky to remember unless you understand why it's there. What is the first number in the pattern? 1. So I don't want to add the 4 for the first one. That's why we take away 1 on the plus 4. Is because for the very first term, you don't want to add the 4 yet. So that's why the n minus 1 is part of the formula. So it's the first term plus the difference of 4, but not for the first term. Okay, so then it says, find the 20th term in the sequence. Well, then this is very easy. A little 20 is going to be 1 plus 4 times 20 minus 1. And you just literally plug that 20 into the end spot, and then you don't have to extend the list all the way out to the 20th number. You can just write the formula for it and then plug it in. So go ahead and put that in your calculator, please. 1 plus 4 times 20 minus 1. And what would the 20th number in the sequence be? 77? Good. All right, take a look at the next one, number 2. My numbers go 7, 2, -3, -5. What's the pattern? -5 each time. Very good. So my common difference is a negative number because I'm taking away 5 each time. Then my A sub n is whatever the first term is. What was the first term for this sequence? What number? 7 minus 5, n minus 1. And remember, the n minus 1 is there because I don't want to minus 5 off the first 7. I want to wait till the second term. Then it says find the 30th term in the sequence. You just take your 30, pop it into your formula. So A sub 30 would be 7 minus 5, 30 minus 1. So 7 minus 5, parentheses 30 minus 1. Okay, that gives me negative 130. So the purpose of the formula is just to kind of like help you get to the later terms in the sequence without having to extend it that far. Okay, take a look at number 3. You're going to notice that number 3 has a little bit of a trick to it. It doesn't give you the first and the second and the third in the sequence. Instead, it gives you the first term, and then it skips all the way to the 11th term. So if you want to know what the difference is, okay, what you're going to have to do is A11 minus A1 over 11 minus 1. Okay, and here's why you want to do that. If I subtract the terms, that'll tell me how big or how much smaller it got. But then if I divide by how many terms passed, I can essentially split it up with how much it jumped each time. So looking at your numbers, what is 52 minus 22? Okay, 30. And then my terms went from 11 to 1. How many is that? How many terms went by? 10. And what is 30 divided by 10? 3. Then my difference is a plus 3 each time. So even though it jumped 30, since it took 10 terms to do that, That's how come you would divide them to know exactly how much it went each time. So now let's write our difference. A sub n equals the first term, which is what number? 22 is correct. Plus 3. But not on the first term. Okay, then it says to find the 13th term, then I can just take the 13 and plug it in. So a little 13 is 22 plus 3, 13 minus 1. And then you can just put that into your calculator to get that answer without having to extend the list. So 22 plus 3, 13 minus 1 gives me 58. Questions on that? Okay, we're gonna do one more. Okay, take a look at number 5. First thing, let's find the difference. Remember, the formula is that you want to subtract the numbers and then divide by subtracting the little numbers. So for my D formula right here, it's going to be 18 minus 15. How many did it go up or down? Oh, hold on. 18 minus 15.
Oh.
3. Okay, and now I want to know how many terms went by. Then I'm going to do 13 minus 7. And how many terms went by? 6. So I'm saying how much did it go up? 3 units. But if it took 6 units to do it, what's 3 divided by 6? 0.5. Very good. Okay, and then notice that I'm putting that little plus just to show that this is an add pattern. I'm adding 0.5 each time. All right, then it says find a sub n. So I'm going to put a sub n equals blank plus 0.5 n minus 1. Now, why am I having to leave a blank here? Because we don't know the first term. So you have a couple options here, but I'm going to say that since we're on the 7th term, we need to go back to 6, 5, 4, 3, 2, 1. How many terms do we have to go backwards? So we're on 7, we want to go back to 1. 6. Then we need to do 6 halves to get back to the original. Does that make sense? So in your calculator, put in 15. And then minus 0.5 6 times. The easiest way to do that is going to be 15 minus 0.5 6 times. Now, quick question. Why am I minusing the 0.5 instead of adding it? Because this is a plus pattern. Because I'm trying to go backwards. That's exactly right. So if I want to go backwards to the first term, instead of adding the 0.5 as many times, I'm going to minus it. So my original term must have been a 12. Okay, but I'm going to put a little star here. You have to go backwards to find the first term. Okay, then it says to find A4. Then you would do A4 equals 12 plus 0.5, 4 minus 1. And you can just literally put that into the calculator. Okay, so we need to cover the pattern for geometric. Do you think we could just keep going and finish it, or do we need a little break? Don't feel okay with going on to the last page? All right, so if it's a plus or minus pattern, you're going to do it just how I showed you. Go ahead and turn the page. There are only 2 types. You already know how to do what. Okay, the other page is going to be if it's geometric. And remember, geometric means it's a multiply or a divide pattern. Your formula is going to be A1 R to the n minus 1. Okay, but notice there's not a plus or minus in this formula because it's not a plus or minus pattern. It's a multiply pattern. So that's why your A1 is multiplied with your R. And then remember, the N minus 1 is to say, don't multiply by whatever that common ratio is for the first term. So taking a look at number 9, try and find the pattern. It goes from 10 to 30 to 90 to 270. What's the pattern?
203.
Times 3 each time. Then my A sub n, I'm following this formula right here, is I want whatever the first term is. What is it in the list? 10. My ratio goes in parentheses to the n minus 1. So it's a little bit of a different formula, but the pieces are all pretty much the same. Then if I want to find the 10th term in the sequence, literally just plug in a 10, put it in your calculator. Now, because you're timesing on these formulas, the numbers do get big a little bit faster than on the other one. But you're plugging in the number where the n is, which is a little number in the exponent up top. So it'd be 10 parentheses 3 up to the 10 minus 1. Okay, if you don't know how to get the up, it's this little arrow right here. Okay, and I got 196,830. But the multiply patterns get big really fast. The divide by patterns get small really fast. Okay, take a look at number 10. Try and find your pattern. It goes from 80 to 40 to 20 to 10 to 5. What's the pattern? Very good. It's a divide by 2, which means for my ratio, I can't use 2. What am I going to do? 1/2 or 1/2. My A sub n is whatever the first term is. What is it? 80. We're going to cut it in half, but not for the first term. That's what that n minus 1 up there stands for. It's not on the first guy. Then if I want the 8th term, just pop the 8 into the formula. So it'd be 80 1/2 to the 8 minus 1. .625. Okay. And actually, if you type this in where you let the base be a pretty fraction, so like 1/2, I think it'll give you the answer as a pretty fraction. Yeah, so that's the same as 5/. Okay, but either one of those are correct. Just know if you do a pretty fraction, it'll give you 1 back. If you do a decimal, it'll give you a decimal back. Okay, let's skip ahead just to number 13. Hopefully we kind of get the idea. Okay, so first thing that I want you to think about is for your ratio, we're going to do A4 and we're going to divide by 18. So that'd be 48 divided by 18. So you're going to do A4 divided by A3. And that's going to give you whatever your ratio is. Okay, so divide them out. What do you get? Now let's do it as a pretty fraction because we need to know what the ratio is exactly. You get 8/3. Okay, good. Now, most of your homework, this is an easier to identify pattern. Okay, but for this one, because it's not like an easy pattern, you would just divide them to know what it is. Okay. So my A1, I'm going to have to work backwards to find, and then I know it's going to be that times 8/3 up to the n minus 1. So we're going to have to do a little bit of work to go backwards to this A1 term. So type into your calculator 18. And we want to undo the times 8/3, yeah? So, and how many times are we going to have to do it if we have the third term? and we're trying to go back to the first term. We have to undo 2 of them. Here's what you're gonna do. If it's a fraction, for example, an 8/3, you're gonna times by 3/8. And that will undo an 8/3. So basically think about, you're just, to undo it, you're flipping it. So I'm gonna times it by 3/8 once, and then I'm gonna have to do that one more time. So I'm gonna have to times it by 3/8 the second time. And that gives me 81/32. That must have been what my first term was. But to undo a fraction, you're gonna flip it and then just times it the number of times that you need to get back to that first term. So my a sub n is 81/32. Times 8/3 was my common ratio, and then up to the n minus 1. Then if it tells you to find the 100th term, you can just type 100 into it and see. Questions on that? All right, your back side of your notes is scratch paper. Okay, but remember, it's 2 formulas. If it's arithmetic, use the first one. Geometric, use the second one.